Ladies and gentlemen, welcome to our YouTube channel. This is Allison Engineering Services. So today we are on site and we are installing the beam and block. And apart from that, we have our engineer on ground today with us. So we are just going to try and interview our engineer today so that you can get to learn more about beam and block. Welcome our engineer, Engineer Samuel.
Thank you so much. I really appreciate you for inviting me today on this site. This is our progress. It's a good progress so far you've made on this site. And I really appreciate you guys for trying this technology. This technology actually is not that new. This technology started way back in 1972. And it's only that in different countries, people are using different codes in construction. So beam and block actually started way back in those days, and actually it's a good thing because it's relatively cheap as compared to this normal way of building, that is casting in situ concrete, the traditional solid slab. So with beam and block, actually, as you can see, it's very easy to install. Those are the advantages that we'll talk about later. And
Okay, just to interrupt you shortly, to give our viewers a better and deeper understanding of the beam and block technology, maybe if you try to explain to us what is the, the distance between the various beams, and apart from that, what is the strength of the beams while trying to create and also install the beam and block technology. Welcome.
okay, thank you so much for that. Those two questions, I really appreciate those two questions so much. I want to explain that. Okay, as you can see, the beam and block, beam to beam or beam to block is not that big. The space between them is not that big. The space should range between 200 millimeter to 300 millimeter, but it should not exceed 1 meter. Yeah, so it should not exceed 1000 millimeters. And again, on the length of the beam are always manufactured on a shorter span. So we always design the beam on a shorter span that is like a one-way slab. And again, on the strength of the beam and block, it is manufactured to BS 15037. So that is the manufacturing process of beam and block. And the block can carry up to 3.5 Newton per meter square.
Briefly, would you kindly just explain to us some of the advantages of this technology, that is the beam and block technology, as compared to the cast in situ concrete method?
Precast beam and blocks, thank you again. Precast beam and blocks are concrete or other composite materials that are manufactured and cured in a controlled environment. And again, I can say, just like any other traditional method is very quite expensive. Number one of the advantages that this beam and block has, precast beam and block has, is the speed and efficiency. Precast beam and block can be manufactured and installed much faster than traditional construction techniques. This can help speed up the construction process, reduce labor cost, and allow project to be complete more quickly. Number two advantage of it, quality control. Precast products are manufactured in a controlled environment, which help ensure consistent quality and reduce the risk of defect. This can help improve the overall quality of the finished structure. And again, number three, I can say cost effectiveness is precast construction can be more cost effective than traditional construction method, as it reduces the need for on-site labor and can help minimize waste. Additionally, precast product can be designed to be more energy efficient, which can help reduce long-term operation cost. And again, versatility. When you talk of versatility, precast beam and block can be designed and manufactured to meet specific project requirements, making them suitable for a wide range of construction applications, including residential, commercial, and industrial projects. And when you talk of durability, precast products are typically made from high quality material and are designed to be durable and long lasting. This can help ensure that the finished structure is to withstand the rigors of daily use and weathering. And again, on the safety of it, precast construction can help improve safety on construction site, as it reduces the need for hazardous materials and processes and can help minimize the risk of accident and injuries. Lastly, environmental benefit. Precast construction can help reduce the environmental impacts of construction by minimizing waste, reducing the need for on-site labor and using materials that are often more sustainable than traditional construction materials. As you can see, it's really faster, and again, what you add on top of it again are those lighter materials, so it has more advantages. And when we talk about even fire resistant, the beams and the blocks itself are hollow inside, so even it reduces that heat. Okay, because the blocks, on the space inside the blocks help you reduce the heat, so it's even far more fire resistant as compared to the traditional solid slab.
Okay, Mr. Engineer, where else can we apply these the beam and block technology while undertaking the construction process?
Okay, thank you once again. The beam and block method is commonly used in building foundations, pavements, and other structural elements because it provides strong and durable structure that can resist for deformation and cracking under heavy loads. The method is also cost effective and can easily customized to suit specific project requirements. Overall, beam and block is a reliable and efficient construction technique that offers numerous benefits in terms of strength and durability and cost effectiveness.
Just before the installation of the beam and block on site, that is, can you please take us through the process of manufacturing the beams and the blocks and the materials that you use in manufacturing of the beams and block?
Thank you again. The manufacturing process for precast beam and blocks typically involve the following steps. Number one, material selection and preparation. The first step in manufacturing precast beam and blocks is selecting the appropriate materials such as concrete, steel, or other composite materials. These materials are then prepared and mixed according to the specific requirement of the project. Number two, forming. Once the material have been mixed, they are poured into molds or forms that are designed to shape the final product. These molds are typically made from steel or other durable materials and are precision made to ensure that the finished product meets the required specification. Number three process is curing. After the materials have been poured into the molds, they are allowed to cure in controlled environment. This can involve placing the molds in specified curing chamber or using other methods to ensure that the materials fully harden and achieve the desired strength and durability. Finishing. Once the material have cured, the precast beam and blocks are removed from the molds and undergo a traditional finishing process such as cutting, shaping, or painting. These processes help ensure that the final product meets the specific requirement of the project and is ready for installation. Number five, what I can say about the quality control. Before the precast beams and blocks are shipped to construction site, they undergo rigorous quality control testing to ensure that they meet the required specification standards. This can involve performing various tests such as compressive test, tensile test, and visual inspection to ensure that the product are safe and durable. And then transportation and installation. Once the precast beam and blocks have been manufactured and tested, they are transported to the construction site where they are installed according to the project's plan and specification. This can involve using specified equipment such as cranes or forklifts to place the precast product in the desired location. Again and again, you can even use manual pulleys to do the lifting processes. Overall, the manufacturing process for precast beam and blocks involve careful planning, precise manufacturing, rigorous quality control to ensure that the finished product are safe, durable, and meets the specific requirement of the project. Thank you.
How about you give us just a comparison between the beam and block technology and the traditional method of construction?
Okay, thank you again. Precast beam and blocks and cast in situ concrete are both commonly used construction materials, but they have some key difference that can affect the choice between them for a given project. Here are some of the main advantages and disadvantages of each method. When we talk about the advantages of precast beam and block, we're talking of speed and efficiency, we're talking of quality control, we're talking of cost effectiveness, we're talking of all that. And when we talk of its disadvantage, which I didn't mention earlier, some of the disadvantages it has, that is the disadvantage of beam and blocks, limited design flexibility. Precast beam and blocks are manufactured in advance and may have limited design flexibility compared to cast in situ concrete. This can make it more difficult to accommodate unique or custom design requirements. Number two disadvantage of it, transportation cost. Of course, this is some of the things that I've experienced so far. You realize that maybe where we have the yard and where maybe that material that is beam and block are being manufactured and the site are too far away. So you get that the client is going to incur a lot of cost on the transportation, uh, on the transportation of manufacturing these precast materials. Advantage of cast in situ are design flexibility. Cast in situ concrete can be customized and shaped on site to accommodate unique or specific design requirement, making it more flexible than precast beam and blocks. And on-site quality control. With precast in situ concrete, quality control can be performed on-site, allowing for more immediate feedback and adjustment to the construction processes. And on the disadvantage of cast in situ are slower construction time. Cast in situ concrete can take longer to set and cure than precast beam and blocks, which can slow down the overall construction process and increase labor costs. Number two, on the disadvantage of cast in situ, increase on-site labor. Cast in situ concrete requires more on-site labor as worker must pour, finish, and cure the concrete on-site. This can increase the overall cost of the project. And again, overall, the choice between precast beam and blocks and cast in situ concrete will depend on the specific requirement of the project, including factors such as design flexibility, construction speed, cost effectiveness. Both methods have their advantages and disadvantages. The most suitable method will depend on the unique needs of the project. Thank you.
As we continue with our interview today, we are just trying to show you what is happening on site. This is the installation of the beam and block method of technology. This is actually a story building, and we are carrying on with the process of the installation of the beam and block method. And another question I know that most of you will be asking themselves is, what's next after the installation of the beam and block? What do we do next after the installation of the beam and the block is done?
So you've asked a very good question. For our viewers here, what do we do next after installing this beam and block? Of course, you can't just leave them the way they are. So what do we do next? After doing this, after installing the whole area, that is after installing beam and block on the whole area, and this is now what we do next. We do a 50 millimeter screeding on top of the beam and block to cover those spaces that might have been left, that might not have been covered by the blocks. And again, we have the finishing work. Depending on the project specification, additional finishing work may be required to complete the structure. This can include tasks such as installing flooring, wall ceiling, and other finishes, as well as performing any necessary painting, staining, or other decoration work. Installation of fixtures and equipment. Once the precast beam and blocks have been installed, any necessary fixtures and equipment such as plumbing, electrical, HVAC, and other systems can be installed to complete the structure. Final inspection and testing. Before the structure is considered complete, it will typically undergo a series of final inspection and testing to ensure that it meets the required specification and standard. This can include performing various tests such as structural integrity test, safety inspections, and environmental testing to ensure that the finished structure is safe and functional. And again, now you have to close the project. Once the structural construction work has been completed, all necessary inspection and testing have been performed, the project will typically undergo a formal closeout process, which can involve submitting final documentation, obtaining any necessary permits and certification, and completing other administrative tasks to formally complete the project. Thank you.
Upgrading to block.
See the new method these people are using to deck their houses. Because of the cost of rods and stones and all those other materials used for decking houses, a lot of people are beginning to adopt this method of using bricks to deck the houses. Now just watch and see how this thing looks, how they do it from scratch. You will see the under of this thing, see how it looks, and see even when they have loaded the house on top of it, you will see how it looks from the under and also from the top. Just watch and see. And for the engineers in the house, we will need to ask this question again and again: how reliable is this thing? Because so many people have argued that this is even more reliable than the regular one we do. You will see the one we do and also look at this one very well to know whether which one you think is better. Keep watching.